Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe.
Hello, future engineers. There is another video in Engineers in Progress on uniform motion continuation. I hope that these sets of exercises will help you improve in your thinking skills, analytical skills necessary in your engineering preparations. So still on uniform motion problems, problem 54. A motorboat which can travel at 20 miles per hour in still water takes 3/5 as long to travel downstream on a river from A to B as to return. Find the rate of the river's current. So traveling downstream means the effective speed is 20 because this is the speed of the motorboat in still water plus the river's current. And the effective speed in returning is 20 minus the reverse current, which we will denote C. So based on this statement, meaning travel time from A to B is equal to 3/5 of the travel time in returning, which is B to A. So let's set up that time in traveling from A to B is equal to 3/5 of the travel time in returning from B to A. Then this time is distance over effective speed, and the effective speed is speed of the motorboat in still water plus the current C for A to B because it is from A to B, that is downstream direction, and PBA is distance, which is the same distance D over 20 minus C. So TAB, distance over 20 plus C, is equal to 3/5 of quantity D over 20 minus C. So let's cancel C, then simplify. We have 1 over 20 plus C equals 3 over 5 quantity 20 minus C. So cross multiply, this is 1 times 5 times 20 is 100 minus 5C equals 60 plus 3C. So 100 minus 5C equals 60 plus 3C. 100 minus 60 is 40, then 3C plus 5C is 8C. So 40 equals 8C. C therefore is 40 over 8, and that is 5 miles per hour. So that's the reverse current, rate of the reverse current, 5 miles per hour. Problem 55. Two rivers flow at the rates of 6 miles and 4 miles per hour respectively. It takes a man in a motorboat as long to travel 36 miles downstream on the first river as to travel 16 miles upstream on the second river. Find the speed of the boat in still water. So we will call that speed of the boat in still water as V. So time is the same. Time in traveling downstream in the first river, river A, is equal to same time, travel time, in going upstream on the second river. But the distances would be different for the two. So time 1 equals T2. T1 is distance 36 divided by V plus 6 because this is the rate of the current in river A. Then the direction is downstream for river A, while T2 is 16 miles, that's the distance, and the motorboat travels upstream on the second river, so the effective speed is v, then minus 4. So 36 over, so d1 over effective speed in river 1 equals d sub 2 equals effective speed in river 2. So distance 1 is 36, effective speed in 1 is v plus 6, then equals distance 2 is 16, and effective speed in river 2 is v minus 4. So 16 over v minus 4. 36 over 16, we can reduce this to 9, divide by 4, then this one is 4. So 9 over v plus 6 equals 4 over v minus 4. Then cross multiply, 9v minus 36 equals 4v plus 24. So 9v minus 4v is 5v. 24 plus 36 is 60. 5v equals 60, so v is 60 over 5, and that is 12 miles per hour. So that's the speed of the boat, motorboat in still water. Next problem, 55. It takes Jordan 60 seconds to run around 440 yards track. How long does it take Arnold to run around the track if he and Jordan meet in 32 seconds after they start together in a race around the track in opposite directions? So the path is closed. It may be circular or oval as long as it is closed. So the speed of Jordan, average speed of Jordan is 440 divided by 60, and we simplify that into 22 over 3 yards per second. Then, of course, distance is the 440 yard distance. They run in opposite directions, so the distance traveled by Jordan and the distance traveled by Arnold in 32 seconds is equal to 440 because they meet after this time, 32 seconds, and they start in opposite directions from the same point. So distance equals distance traveled by Jordan plus distance traveled by Arnold. So 440 equals, so the travel time is 32 for both. So 440 equals speed of Jordan times 32 plus speed of Arnold times 32. So we'll call the speed of Arnold as V sub A, then times 32. Simplifying this equation, so 440 minus 22 times 32 over 3 is 616 over 3 equals V sub A times 32. So 616 over 3 divided by 32, that's the speed of Arnold, and that is 77 over 12 yards per second. So since the question is how long does it take Arnold to run around the track if he and Jordan meet in 32 seconds after they start together in a race around the track in opposite directions? Since the speed of Arnold is now known, then to compute for that time, so distance equals speed of Arnold times time of Arnold, travel time of Arnold for this 440 yards. So 440 equals 77 over 12 times travel time of Arnold to complete that 440 yard track. So time of Arnold is 440 times 12 over 77, and that is in mixed fraction 68 and 4 over 7 seconds. So that's it for this problem. Then the last, an airplane could travel a distance of 1,000 miles with the wind. In the same time, it could travel a distance of 800 miles against the wind. If the wind velocity is 40 miles per hour, what is the speed of the plane? So we are talking here the speed of the plane in still air. So for our starting equation, we have the same time here. Time in flying with the wind for the airplane is equal to time in flying back, or time in flying against the wind. So that's the starting equation. Since time is distance over effective speed, So distance with the wind equals speed, effective speed with the wind, then equals distance against the wind, travel distance against the wind divided by effective speed against the wind. The effective speed with the wind is V plus 40, while the effective speed against the wind is V minus 40. Distance is 1,000 miles over V plus 40, then equals 800 miles over V minus 40. 1,000 over 800, we can reduce that to divided by 200, so 5, this is 4. So 5 over V plus 40 equals 4 over V minus 40. Cross multiply 5V minus 200 equals 4V plus 160. So 5V minus 4V is V, and 160 plus 200 is 360. Therefore, V is 360 miles per hour. So that's it for this video.